So we are looking at this problem, diameter of a binary tree. Given root of a binary tree, we need to return the length of the diameter of the tree. What is the diameter of a tree? So this is the longest path between any two nodes in a tree. So if we talk about this node, this node, this would be our diameter. If we talk about this node and this node, this would be a diameter. We are supposed to find the longest diameter. And what does it mean by the longest? So it has defined length. By length, it means the number of edges, the length of edges, not the number of nodes in a diameter. So in this example, it would be 1, 2, and 3, and we have an output of 3. So this is the question. Let's see how do we solve it. Let's say we are given a problem like this. To calculate the diameter, we can take a very naive approach. Let's go to every node and calculate the diameter from that node and keep a track of the diameter maximum. So we are on this node. Let's look at the longest over here, the longest path over here. Let's look at the longest path over here. Let's say it's L1, let's say it's L2. So the diameter on this node would be L1 plus L2. Similarly, we can go to this node and calculate the diameter from here to here. We can keep doing that for every node, and eventually we would have a diameter maximum, which would be the maximum value of this diameter. Now, in this approach, we can observe something, that we are solving some of the sub-problems again and again. This tree is being solved also by this subtree. This subtree is solved by this subtree. So instead of solving the same problem again and again, we can take an approach where we go bottom up instead of top down. To do that, every node can return the length of the longest path. For the leaf node, it would be 0. For this parent node, it would be the longest of the left subtree and the right subtree, which is 0 and 0, plus this length, which would be 0 plus 1, so 1 over here. For this node, it would be the longest path. Visually, we can see it's 1 and 1, 2. If we want to calculate that, it would be the length of the subtree, the maximum length. Over here, it's 1 plus this length plus 1. So this would be equals to 2. If we look at this particular node here, this would be again 0. What about this? 0 plus 1. It would be 1. For this node, it would be 1 plus this one, 2. For this node, it would be the longest here and the longest here. The longest here would be 0, and we would pre-calculate it. And so plus 1 and plus 1. So on one direction, it would become 1. On the other direction, it would become 3. So we would take the longest 3. So we can say that from this node, its subtree has a length of 3, which is true, like 1, 2, and 3. For this node over here, we can say, let's take the longest of the two side. Visually, we can see that the right side is the longest. So here we can say that it's 1 plus 3. This value equals to 4. So we can say that the right side has a length of 4, including this edge. And the left side has a total length of 3, including this length. So diameter can be said L1 plus L2, which is 3 plus 4. We have a diameter of 7. Now this can be done for every node, starting from the bottommost nodes to up. Every time we calculate the value of diameter, we can store the maximum diameter value in diamax. Let's look at the code implementation of this problem. So here I am in the code editor. First of all, I would like to create a variable called diamax. I would assign it to 0. I do not have any length at this point in time. After that, I would like to create a function which returns me the longest length of a subtree. So let's call it def length, and this would take the root. This would take the root node over here inside that. Now this length would be a depth first function. It would go deep into the tree. So for that, I need to call this function over here. Length, I would call it for the left subtree, root.left, and I would get a length, let's call it L. Then I would call it for the right subtree, root.right. These will give me the length of the longest path on the left subtree and the length of the longest path on the right subtree. I can call, I can initialize a variable diameter, which is left plus right. I can also check if this diameter is the maximum. If it is, then I store it. So I can say non-local variable. I want to use this variable diamax. I can say diamax is equals to max of this diameter or what I already had, diamax. Now this value would be changed if the diameter is the maximum so far. Over here, I can return from this function, return. So I need to return the maximum length, treating this entire tree as a subtree. So if I was over here, if the value of root was 2, then I want to return from here to 1 the longest length out of this entire subtree, So I can say the maximum of length of L, which is L or R, and I have to add its own length over here, which would be plus 1. I also need to handle the leaf node, which would be if not root, let me return 0. 0 because the length after this is 0, so we would return 0 from here. After that, I would call this length function, passing the root of the tree, and I would return the diamax which is needed. So we are calculating length over here, which is not going to be returned as a response. This is the reason why we needed a new function. Let's try to run and see. It's passing. Let's submit it. We have a solution over here.